back. This is Ramas and it's me, Priska Joseph. So in this class, we are discussing the part 2 of the chapter Real Numbers. Before entering into the video, if you're watching my channel, please subscribe it and don't forget to hit the bell icon for the notifications. And your comments are valuable for me. I'm eagerly waiting for your comments. So let's start. And it's fundamental theorem of arithmetic. What is fundamental theorem of arithmetic? That is, every composite number can be expressed as a product of primes, and this factorization is unique apart from the order in which the prime factor occurs. Once again, every composite number can be expressed as a product of primes, and this factorization is unique apart from the order in which the prime factors occurs. Okay, so every composite number. Let us take an example, that is 15 is a composite number, right? Okay, 15 is a composite number, and every composite number can be expressed as a product of primes. Okay, so what are the factors of 15? It is 3, 5, 1 and 15. Okay, that is 3 times 5 is 15. Okay, see, every composite number can be expressed as a product of primes. Okay, product of primes. See, these 3 and 5 are prime numbers. Okay, so this composite number 15 can be represented by the product of two primes, that is 3 and 5. Okay, so first session, every composite number can be expressed as a product of primes. Okay, these are prime and this is composite number. Okay, did you get me? Now, and this factorization is unique. Okay, this factorization is unique. What does it mean? See, only 3 into 5 will get 15. Only 3 into 5 get 15. Okay, no other numbers can multiply and we get 15. If we multiply any other number, we never get this 15. Only 3 into 5 get 15. That is, this factorization is always unique. Okay. For example, in the case of 16, if we take 16, what are the factors of 16? It is 4, 1 and 16. Okay, this 4 into 4 get 16. Okay, also 2 into 8. Okay, so 2 and 8 are the factors, and 2 into 8 we get 16. Okay, which means this factorization is unique. Okay, this factorization is always unique, no matter of the order of factors. For example, if 15 can be represented like 1 into 15 or 15 into 1. Okay, then 3 times 5 or 5 times 3, whatever it is, there is no importance for the order. And so this is the theorem. If we take another example like 64. Okay, we take 64. How can we factorize this 64? Listen, this is 64. First, we have to factorize it with 2. We get 32. Again, by 2, we get 16. And again, it is 8. Now it is 4. 2 into 2. Okay. 1, 2, 3, 4, 5, 6. That is 2 to the power 6 is the to the power 6 is also considered as 64. Either or we can write 64 as 2 times 32. See, 2 is a prime but not 32 is not a prime number. Okay, then by factorizing this 32, we can write 2 to the power 5. Okay, or then we can write this 64 as 16 into 4. Okay, here 4 and 16 both are composite numbers. We have to rewrite like 2 to the power 4 into 2 to the power 2. Okay, so this is the theorem. That is, every composite number can be expressed as a product of primes like this, and this factorization is unique. Okay, we already said it. Apart from the order in which the prime factors occurs. Okay, no matter the order of the prime numbers, prime factors. Okay, hope it is clear for you. If you have any doubt, please ask me in the comment section. And this is the fundamental theorem of arithmetic. Okay, so now let's discuss a simple question. It is, consider the number 4 to the power n, where n is a natural number. Check whether there is any value of n for which 4 to the power n ends with the digit 0. Once again, consider the number 4 to the power n, where n is a natural number. Check whether there is any value of n for which 4 to the power n ends with the digit 0. Okay, so this is the question. Now, what is 4 to the power 1? Which is 4. If 4 to the power 2 is 16. Okay, then 4 to the power 3 is equal to, what is it? 16 times 4, which is 64, and so on. This number series will be gone. Okay, so here in this case, if we consider the number 4, then 4 to the power n always ends with a number 4, 6, again 4, and so on. It never ends with 0. Why? We consider 20, and if 20 to the power 1, which is equal to 20, then 20 to the power 2, it will be 400. Okay, what about 20 to the power 3? It will be 800, that is 8000. That is 20. That is 20 can be written like this. 10 here, 10 is there. Then 2, 5. That is 2 into 5. This is 20. Okay. So here what's happening is 2 into 5, the whole raised to 1, which is equal to 20. Second step, 2 into 5, the whole square. That is again 2 into 5. Okay, which is equal to 400. Now in the third step, 2 into 5, 20 to the power 3. Okay, so 2 into 5 into 2 into 5, again 2 into 5, which is equal to 8000. So in this series, all the one digit numbers are 0, which means any number which have 2 and 5 as factors, then its ones digit always will be a 0. Okay, this question, here it is 4 to the power n. What are the factors of 4? It is always 2. Okay, so by considering this number, we can't say that any value of n, it will never ends with a digit 0. Okay, hope it is clear for you. So this is the answer. Now, next topic is LCM and HCF. By using factorization method, we have to find out LCM and HCF of any two numbers. Okay, so let's start. Here, given 6, 20, we have to find out LCM and HCF. What is LCM? LCM is least common multiple. Okay, common multiple. And what is HCF? This is highest common factor. Okay, so 6 and 20. First we have to factorize these two numbers. So factors of 6 is equal to, it's 2 into 3. Okay, then next is 20. So what are the factors of 20? 20 can be written like this, 10, 5. Okay, so 2 into 5, that is 2 square into 5. Now, what is LCM? LCM is, listen carefully, using the factorization method, LCM is the product of all factors with highest powers. Okay, product of all factors with highest powers. Listen carefully. Here 2 is a factor. See here in 20 it's 2 square. Okay, so product of highest factor, that is 2 square. Here it is 2 to the power 1 and 2 to the power 2, which is highest value, 2 to the power 2. Okay, so let's take 2 square. Okay, then what is the next factor, which is 3. Okay, 3, and next one is 5. Okay, so 2 square is 4, 4 into 3 into 5. 4 times 3 is 12. 12 times 5 is 60. Okay, so the LCM is 60. Did you get me? Remember, LCM is product of all factors with highest power. Okay, then what about HCF? HCF is the product of common factors with least power. Okay, so between these two numbers, which is the common factors? And 2 square is there. Will be considered. 2 should be considered. Why? In the case of a factorization method, the HCF is considered as the common factor with least power. Okay, so HCF is 2. Okay. Hope it is clear for you, and we will discuss more questions later. Okay, so this is the answer. Now there is an important relationship between LCM, HCF and the two numbers. Okay, what is it? That is, if the two numbers are A comma B, then A into B is equal to HCF into LCM. Okay, so product of two numbers is equal to product of their HCF and LCM. In the previous question, that is 6 comma 20, their LCM is 60 and HCF is equal to 2. We already get the answer as LCM 60 and HCF 20. Sorry, HCF 2. Now let's, by using these numbers, we have to find out that we have to verify this statement, that is A into B. A and B are two numbers, that is 6 into 20, which is equal to HCF. HCF is 2 into LCM. LCM is 60. Okay, so 6 into 20, which is 120, and 2 into 60, which is also 120, hence verified. Okay, so remember this relationship, that is A into B, that is product of any two numbers is equal to product of their HCF and LCM. Okay, so that's it. Remember all this concept very well. Okay, by using these theorems, we have to solve many problems. Okay, these are some important concepts of this chapter. Study all this concept very well. Next class we will discuss exercise problems. Okay, so that's it. Once again, thank you so much. Have a nice day.